Say, I given first program, write a program to display factors of a given number. Write a program to display factors of a given number. Suppose 6. 6 factors are 1, 2, 3, 6. So 1 is a factor, 2 is a factor, 3 is a factor, 6 is a factor. Suppose 7 factors. 1, 7. 1 and 7. See, first this number you have to accept. Either 6 or 7, whatever you want, you can accept. After accepting that number, 1 to that number, each and every number you have to apply with a division operator, modulo division operator. If remainder is 0, it is factor. If it is remainder is not 0, it is not a factor. If it is a factor, you have to display. First, how to accept data dynamically from keyboard? Scanner class. What we have to write? Scanner S equal to new scanner. System.in. Till I didn't explain about this line. Not completed. Okay. Scanner S equal to new scanner system.in. Scanner class in which package? Java.util package. This is required. So for this line purpose, this is required. Now, system.out.print, enter any number. One number you will accept. The number you have to store in one variable. Something x. S dot next int. Say, enter any number displayed on monitor. Whatever you enter, that is received, stored in X. For this next int method purpose, scanner class reference required. Scanner class object reference. For this is required. Okay. Now, here one number accepted. This number may be 6 or 7 or 10 or 100, whatever you want, you can enter. 1 to given number, one loop you have to write. How to write? For int I equal to 1, I less than or equal to x, I plus plus. In this, each and every number, whether it is factor or not, you have to check. If x modulo division I, if double equal to 0, then system dot out dot println x, I over. This is factors program. See, first demo class loaded. No, first demo class loaded. Main method called scanner class object created. This scanner class in java.util package imported. Enter any number displayed on monitor. Whatever you entered received by x. 1 to x, 1 number, it is checking. Suppose if the value is 6, suppose assume 6. I value 1. 1 less than or equal to 6, true. 6 modulo division 1, double equal to 0, true. Then 1 printed. It will become 2. 2 less than 6, true. X modulo division, 6 modulo division 2, 0, true. Then 2 printed. Like that 3 printed. When 4 comes, 6 modulo division 4, 2. 2 double equal to 0, false. It won't print. 5 comes. 6 modulo division 5, 1. 1 double equal to 0, false. Then it won't print. Again 6. 6 less than or equal to 6. 6 modulo division 6, true. 0 comes, true. 6 printed. 7. 7 less than or equal to 6, false. Stop it. See, file, save. Java C demo.java. Java demo. Say enter any number 6. 6 factors. 1, 2, 3, 6. Java demo. Enter any number. 8. 8 factors. 1, 2, 4, 8. 1 8 ja 8. 2 4 ja 8. 4 2 ja 8. 8 1 ja 8. 8 modulo division 1, 0. 8 modulo division 2, 0. 8 modulo division 3. You will get it 2. So not a factor. 8 modulo division 4. You will get a 0. 8 modulo division 5. You will get a remainder 3. Not a factor. 8 modulo division 6. 2. Not a factor. 8 modulo division 7. 1. Not a factor. So 8. 0 comes. Like this. Say Java demo. 5. 1 and 5. No other factor. Java demo. 7. 1 and 7. No other factors. So it is factors program. Write this program. Program to display factors of a given number. Program to display factors of a given number. Those who did, no need to write. Program to display factors of a given number. Program to display factors of a given number. If you write 2 forward slashes, it is considered as comment. This comment ignored by the compiler. Program to display factors of a given number. Whichever number you enter, that number factors displayed. Say about scanner class, till I didn't explain. About system.out.println also till I didn't explain. That in further sessions we'll see. It will accept one number, 1 to that number, reminder it will check for every number. If it is 0, factor, then print it. Is it over? Say first one number accepted, the value stored in X. 1 to X. Given 1 to given number loop. Each and every number reminder it will check. If it is 0, then printed. If reminder is 0, it is called factor. If reminder is 0, it is called factor. So that is printed. Is it clear? Okay. Say X value 6. X value 6. Assume. X value 6. I value 1. 1 less than or equal to 6. 1 less than or equal to 6? True. Then it will enter x modulo division 1. 6 modulo division 1. 6 modulo division 1? 0. 1 6 is 6. Remainder 0. So equal to 0. It is true. Then it is printed. So output 1. 1 printed. After printing, I becomes 2. 2 less than or equal to 6. True. 6 modulo division 2. 2 3 is 6. Remainder 0. It is true. Then printed. 2. I becomes 3. 3 less than or equal to 6. True. 6 modulo division 3. 6 modulo division 3. 3 2 is 6. Remainder 0. So 0 double equal to 0. True. 3 printed. Next, I becomes 4. 4 less than or equal to 6. True. 6 modulo division 4. Remainder 2. 2 double equal to 0. False. It won't print. I becomes 5. 6 modulo division 5. 1. 1 double equal to 0. False. It won't print. 6. 6 modulo division 6. 0. It is printed. 7. 7 less than or equal to 6. False. Stop it. Now, whichever number you enter, that number factors displayed. Whichever you enter. See, Java C demo.java, Java demo. See, 24. See, I entered there. Okay. 24. See, 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 8 is a factor, like this. Java demo. Enter any number, 25. See, 1 is a factor, 5 is a factor, 25 is a factor. Now, any number, Java demo, 284. 284 factors. Any number you can enter. That factor is displayed. This is first program. Second program, sum of the factors. So, sum of the factors. Sum of the factors, now factors no need to display. Sum you have to display. One variable you can take. Integer sum equal to 0 or total equal to 0. That sum you can add. Sum equal to sum plus I. When for loop terminated, system.out.println sum. All factors added. So, program to display sum of the factors. See, suppose value 6. Some factors, what are the factors? 1, 2, 3, 6. It is 1, 2, 3, 6. If you add 1 plus 2 plus 3 plus 6, what is the result? 12. So 12 is output. Okay. Suppose 7 factors. What are 7 factors? 1 and 7. 1, 7. 1 plus 7, 8. This is sum of the factors. So, each and every factor added to sum. When for loop terminated, sum printed. See, file, save. Compilation, execution. 6. 6 factors, 1, 2, 3, 6. 1 plus 2, 3. 3 plus 3, 6. 6 plus 6, 12. Java demo. Enter any number, 7. 7 factors, 1 and 7. 1 plus 7, 8. 5 factors, 1, 5, 6. This is sum of the factors. See, second program to first program, only this is changed. That's it. Write this program. Program to display sum of the factors of a given number. This second program. Program to display sum of the factors of a given number. So first program to second program, little bit change. Little bit change. Program to display sum of the factors of a given number. Whichever number you enter, that factors sum calculated printed. I'll share second assignment also. Okay, second assignment I'll share today. See, first program to second program, little bit different. Just add it to sum. That's it. Factors are added to sum. Is it completed? Next program, perfect number. Sum of the factors, if it is equal to given number, that is perfect number. This program only, little bit different. Okay, program to program, little bit different I given. Okay, say, suppose 6 factors. What are 6 factors? 1, 2, 3, 6. Okay, 1, 2, 3, 6. Except 6. Except given number. If you add 1 plus 2 plus 3, result is 6. It is called perfect number. Suppose 7. 7 factors, 1 and 7. Except 7. Except 7, 1. Then it is not a perfect number. Now 1 not equal to 7. So sum you have to compare with x. If it is equal, perfect number. Not equal, not a perfect number. Just here less than or equal to a given, less than you have to write. That's it. Because last number not included. Okay. Then what you have to do, see here less than or equal to written, only less than. Here what you have to do is you have to check if sum double equal to x. given number is perfect number. Else, given number is not a perfect number. Over. Say program to check whether given number is perfect number or not. More than one line is there, comment we have to write like this. If comment is more than one line, we can write like this. Comment syntax. More than one line is there, forward slash star, n number of lines you can write star forward slash. Otherwise, every line 2 slashes you have to write. Now, you observe file, save, compilation, execution. 6. Is it perfect number? Yes. Given number is perfect number. 7. Is it perfect number? No. Given number is not a perfect number. Suppose 14. 14 factors. 1, 2, 7. Except 14. 1 plus 2. 1 plus 2. 3. 3 plus 7. 10. It is not a perfect number. Okay. So given number is not a perfect number. Like this, you can check. Write this program. Program to check whether given number is perfect number or not. Program to check whether given number is perfect number or not. Program to check whether given number is perfect number or not. If comment is only one line, 2 forward slashes we can write. Comment is more than one line, forward slash star starting, star forward slash ending. Like this you can write. Program to check whether given number is perfect number or not. If it is perfect number, given number is perfect number printed. For not a perfect number, given number is not a perfect number. Just some value we are comparing with X. Here equal to symbol I removed. First program to second program little bit different. Second program to third program also little bit different. Now next fourth program also same. Is it over? Now is it over? Now fourth program, write a program to display all perfect numbers from 1 to 1000. Just x value 1 to 1000 you have to take. That is one more loop you have to write. That's it. This program only. Here x value you are accepting. Now accepting not required. 1 to 1000. One for loop you can write x value 1 to 1000. See. Now just now no need to accept. No need to accept. X value you have to take 1 to 100. 1 to 1000. Integer x equal to 1. X less than or equal to 1000. X plus plus over. If it is perfect number, now no need to print like this. That number you have to print x value over. See, x value 1 to 1000. First x value 1. 1 perfect number or not, it will check. If it is perfect, printed. Next to x value 2 comes. 2 is perfect or not, it will check. It will print. 3 comes. 3 perfect number or not, it will check. It will print. So like that up to 1000, it will check. See, now this util package not required. Program to display all perfect numbers from 1 to 1000. Program to display all perfect numbers from 1 to 1000. Now see, here 1 to 1000 one loop I written. One number checked. Is it perfect or not? If it is perfect, printed. File, save. Compilation, execution. Only 3 perfect numbers are there. 6, 28, 496. Only 3. These 3 perfect numbers. Okay. Write this one. Program to display all perfect numbers from 1 to 1000. Program to display all perfect numbers from 1 to 1000. So 1 to 1000 one loop. One number comes. Whether it is perfect or not, it will check. It will print. If it is perfect, printed. Same logic applicable. Next, fifth program also same. Only given range. Now here 1 to 1000 I given. This starting number, ending numbers you have to accept. Fifth program, write a program to display all perfect numbers in a given range. Now here 1 to 1000 range I given. That range I can accept from keyboard. That range you can accept from keyboard. Is it over? Say here what you can do is write a program to display all perfect numbers from in a given range. Then what you can do here, you have to import the package java.util.star. Here scanner s equal to new scanner system.in. Print enter starting number where you want to start. One variable name start. Yes dot next in. Enter ending number. Variable name suppose end. S dot next in. Now what you can do here, one place start, 1000 place end, over. Now given range, starting number you are typing, ending number you are typing, starting to ending. It is perfect or not, every number it will check. Say compilation, execution. Enter starting number, suppose 100. Enter ending number 200. Now it will print 100 to 200. 100 to 200, perfect number is not there. Now enter starting number 1. Enter ending number 50. Two perfect numbers are there. Okay, like this. Write this one. Program to display all perfect numbers in a given range. Program to display all perfect numbers in a given range. Is it over? Total 12 programs are there in assignment. 5 I explained. Okay. Remaining 7 you try to complete by tomorrow. Tomorrow till if you don't get, I'll teach. Okay. 5 programs I explained. Remaining 7 you try to complete by tomorrow. Tomorrow if you don't get, I'll teach. Okay. Is it completed up to here? Writing is over. Which concept you are learning? Methods. What is method? Group of statements into a single logical unit is called as method. What is the purpose of method? To perform the task. If you want to write any task code, method required. Suppose calculating, displaying factors, calculating sum of the factors, and whether it is perfect number or not, it is a task. That code we are writing in a method. That is main method we are writing, any method. If you want to perform any task, that task code you can write inside the method only. Advantages of methods: modularity, reusability. That is how to explain, not completed. How many categories of methods? 4. What is first one? Methods with arguments and with return value. Second one, with arguments without return value. Third one, without arguments with return value. Fourth one, without arguments without return value. 4 combinations. Now you are learning first one. See first one. One method example you studied. Add is a method. This is you studied as last class, which takes 2 integers, which returns 1 integer. Here int c equal to a plus b. Return c. Here. Now add is a method which takes 2 integers. Add is a method which takes 2 integers. It will add. Result stored in C. C will be returned. Okay. C will be returned. But here not only variable. You can write directly literal also. You can write expression also. Say directly return a plus b also you can write. Directly number you can write. Variable also valid. Expression also valid. And literal also valid. All are valid. Okay. Add is a method which takes 2 integers. Here it will add. Result stored in C. The C value returned. This is add method. Is it instance method or class method? Instance method. How do you know that is instance method? Without static. If there is no static, it is called instance method. How many ways to access? 2 ways. What are those? Object reference. Now, it is returning integer. So, int x. That variable name, whatever you want, you can write. New demo. It is object created. Dot add. 2 numbers I am passing. System dot out dot println x. Int y. Here object reference I'll use. Demo d equal to new demo. Here d dot add. 2 numbers I'm passing. System dot out dot println y. See, demo class loaded. Main method called. Object created. With that add method called 2349 copied in A and B. Result copied in C. Return value copied in X. Printed. Object created. Object reference created. With that reference add method called 9923 copied in A and B. Result copied in C. Return. That value stored in Y. Y printed. Here task code I divided into 2 modules. This is one module. This is one more module. This module contains addition of 2 numbers code. This module contains calling that method. So this is called modularity. task you can divide into number of pieces. That is called modularity. Further, what we'll do, we are not going to write complete code in the main method only. We are going to divide into number of methods. Suppose while developing project is it only one program? No. One project may contain hundreds of programs. Each program may contain hundreds of classes. Each class may contain hundreds of methods. Like that, we are going to divide. That is called modularity. Okay. Dividing your task into number of modules. It is nothing but modularity. This code reusable. It is adding 2349 also. It is adding 9923 also. But I written code only one time. But I am calling here also calling, here also calling. Reusability. This code is reusable. That is the reason I given notes, advantage, modularity, reusability. Okay. This is the first method you studied. Now, I'll give another method. This is already written. Now, I want to calculate cube of given number. I want to calculate cube of given number. Method name cube, which takes one integer. After that, result integer type returns. Now, here, int b equal to a into a into a. Return b. Now, cube is a method which will calculate the cube of given number. Cube calculated, result stored in B, return B. B integer type, that's what integer type. Is it instance method or class method? How many ways to access? What are those? When we have to use object? Only one time. When we have to use object reference? More than one time. Now, I want to call both. How to call? Give me answer, you can give answer. How to call this method? By using object. Int x equal to new demo dot cube one number. See, object created with that object cube method called 5 copied in A. 5 into 5 into 5, 125 copied in B. Return B. The B value copied in X. How to print? System.out.println X. By using object reference, I want to call. How to call? Demo D equal to new demo. Next. Return type. Int Y. D dot cube. One number. System.out.println Y. Now, here object created, that object referred by D with that cube method called 8 copied in A. 8 into 8 into 8 result copied in B, return B. The B value returned copied in Y, Y printed. File, save. You observe? Compilation, execution. 5 cube 125, 8 cube 512. Okay. Write this program. I'll explain. Listen. Is it completed? See, demo class loaded, open brace executed, main method called, open brace executed, here object created, with that object cube method called, then 5. This 5 copied in A. Here we are calling cube method, cube. This 5 copied in A. 5 into 5 into 5, 125 copied in B. Return B. P integer type. Here that's what return type integer we specified. Return B. This value copied in X. That 125 printed. Object created. That object referred by D. With that cube method called. Then 8 copied in A. Result 512 copied in B. Return B. That B copied in Y. Y printed. So here what will be happen is this 5 copied in A. Like this. Here copied. Int A equal to 5. 5 is here, A is here. Return B. This B copied in X. This is nothing but int X equal to B. Now, what is the first category name? What is the first category name? Methods with arguments with return value. With arguments with return value. So with arguments with return value. Like this will be there. Second category with arguments without return value. With arguments but no return value. Third category without arguments, only returning will be there. Fourth category without argument, without return, nothing will be there. Okay. Here sending will be there, receiving will be there. Here only sending will be there. Here only receiving will be there. Here no sending, no receiving. Here what we are sending 5. What we are getting 125. Sending is there, receiving is there. That is first category. Only sending, no receiving. Second category. Only receiving, no sending. Third category. No sending, no receiving. Fourth category. Like that, 4 categories of methods. See, we are sending 5. We are getting 125. Sending, receiving. Both are there. Here, only sending will be there. Here, only receiving will be there. Here, no sending, no receiving. Okay, like that, 4 categories of methods. In this method components I'll explain. Components. For that, one more example I'll write. Suppose I want to find the maximum of 2 numbers. Then method name max, which will take 2 integers. It will return 1 integer. What we have to write? If A greater than B, return A, else return B. This method I want to call by using object. What we have to write? What do you write? Int X equal to new demo dot max. 2 numbers you can pass. Next, system dot out dot println X with object reference. Demo D equal to new demo. Next, and Y equal to D dot max. 2 numbers you can pass. System dot out dot println Y. Over. It is okay. Now This is finding maximum of two numbers. Say here, what will be happen? See, demo class loaded, main method open brace executed, main method called open brace executed, object created, max method called 8345 copied in A and B. 83 greater than 45 true. Then A value copied in X printed. Object created, object reference created with that max method called 98 194 copied in A and B. Here 98 greater than 194 false. Return B. B copied in Y printed. Now here this is with object reference finding maximum of two numbers I given. Write this code. Third example. In this program, method components I'll explain. Method components I'll explain. Or I'll explain method components. Just I'll decrease the font size. You observe here. What is max here? Method name. Int A, int B, arguments. Method name and arguments. If you write, it is called method signature. Don't write. First listen. Don't write. Method signature. Method name and arguments. Method name and arguments is called method signature. And return type and method signature is called method declarator. Method declarator. method declarator. Okay. Open brace to close brace. Open brace to close brace. It is called method body. It is called method body. It is called method body. And declarator and method body. This totally called method definition. Method definition. See, method name and arguments is called method signature. Return type and method declarator, method signature is called method declarator. Open brace to close brace, method body. Total complete code, method definition. Okay. Here, return A, return B. These two called return statements. Return statements. Return statements. And here, this line are called method call statements. Method call statements. These two lines are called method call statements. And what are the arguments you are passing here? Here are called actual arguments. Actual arguments. What are the arguments we are writing here? These are called formal arguments. Formal arguments. Arguments, formal arguments also you can call, formal parameters also you can call. Formal parameters. Here actual arguments also you can call, for actual parameters also you can call. Parameters and argument both are same. Say once again, method name and arguments is called method signature. Return type and method signature is called method declarator. Method declarator. Okay. Say method name and arguments is called method signature. Return type, method signature is called method declarator. Open brace to close brace, method body. And declarator and body, method definition. Return keyword lines, return statements. For calling this method definition, two statements are written in the main method. Method call statements. What are the arguments you written inside the method call statement? Actual argument. You can also call actual parameters. Whatever is received here, formal argument or formal parameters. Right, this one. These are method components. Method components. Is it completed? Last questions, give me answer. Method name arguments. Method name and arguments is called method signature. Return type and method signature. Method declarator. Declarator. Declaration comes further. Declaration means semicolon will be there. This is a declarator. Open brace to close brace. Method body. Method declarator and method body. Method definition. Method definition. Written keyword line. Return statement. Okay. For calling method definition, some statements we written in the main method. Method call statements. What are the arguments I passed in method call statement are called actual arguments. Actual arguments we can also call actual parameters. And what are the arguments we written in method definition are called formal arguments. Formal arguments we can also call formal parameters. Okay. Here arguments, parameters both are same, but actual formal difference is there. Whatever you are passing from main method, that is actual. Whatever is received, formal. In a method call statement, if you write actual, in a method definition, if you write formal. But here also argument, there also argument. Here also parameters, there also parameters. You can call. Okay. Is it over? We'll see continuation tomorrow.